Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome to our course. This is cryptocurrency stock time series analysis and forecasting with Python and Facebook Profit. We'll also have a bit of pandas and matplotlib thrown in there. In this lecture, we're going to introduce the project of this course. So first, we're going to load in a crypto prices dataset. I will include that for you in the source files section of this course. That's going to be that last lecture in this section. And as well, I'll show you how you can actually fetch a data set of any stock price you want, whether that's of a cryptocurrency or another stock, from the web. So you don't have to use the data set I'm using. I'll provide it for you for reference, but you can extend this project to use any data set you want. So this data set is going to have about 5 years worth of data on Bitcoin prices all the way from 2016 to 2021. And it's going to have the value of Bitcoin on that date. First, we're going to visualize our data set. So we're going to be able to visualize the trend in the Bitcoin price. I'll show you how we can do that algorithmically. Then we're going to use Facebook Profit to build a machine learning model that will predict the price of our stock using time series and forecasting. So the result, we're going to be able to analyze the model performance. We're going to perform cross-validation and calculate different error metrics like mean squared error. And we're going to be able to visualize our model's results versus our actual data points. We'll also have an upper and lower range for our model's prediction. And then we're going to extend not just a daily prediction, but we're going to work on building a monthly and a weekly prediction as well. And at the end of the course, we'll compare our different strategies. We'll compare the final predicted stock price of our different strategies. And that is going to be the course. All you need to take this course is some programming experience in Python, which we will include for you a section on how to program in Python. As well, you'll need that data set. I'll provide that for you. When we get to building out the project, I'll have that data set for you. And as well, you'll need a code editor. We'll be coding in an online code editor known as Google Colab. I'll show you how you can find Google Colab once we get there. It's completely free, so you don't have to download or install anything to take this course. All right, very exciting. This project is fun. It's very accessible for beginners, very easy to understand. It's a great way to get up and running with a machine learning model very quickly because Profit makes it quite easy for us. All right, I'm excited to show you how we can build out this project. So join me coming up in our next section. Hello, everyone, and welcome back to our course. In this lecture, we are beginning our project of our Bitcoin time series Python machine learning. All right, so we're beginning here in Google Colab. Join me by navigating to colab.research.google.com. This here is an online code editor that we are going to use in order to code in Python. We're going to build our whole project here in a Colab. You can also follow along in your own code editor, but it has to have Python support. All right, first steps first, we are going to load in our data. So I've actually found data from an API. For example, I'll include for you a link if you're interested in scraping the latest data for any kind of stock that you want. In my case, I'm going to be using Bitcoin for this project. So you can visit quandl.com/tools/API. And here you can access data for any kind of coin you want. For example, let me show you if I go to this link of quandl.com/data/bchain for blockchain, and then I go to the MKPRU Bitcoin market price USD. I'm going to navigate to that link, and that is going to take me over to that API page. You do have to be logged in if you want to see the data. But what this gives you is it gives you data about the Bitcoin market price. It also has the frequency, and you can select the type of data that you want, as well as the dates, so the time. Now, I'm not logged in right now, so that's why it's not showing me, but to create an account is completely free. Okay, so I have gotten a CSV file from that API, and you can as well. I've also included it for you in the source files of this section, so just find that in the source files section at the end of this section. And I can open it for you here in a text edit. Preferably, it's best to open these files inside of something like Excel or Google Sheets. But this is the file. What we get is we get the date, and then we get the value of the Bitcoin on that date. So I've started here at 2016/0101, January 1st, 2016. And then look at this. I've gone all the way to 2021, March 2nd, where the price of Bitcoin climbed to 49,000. The first column is the index, counting off the rows. The second column is the date, and the third column is the price of Bitcoin at that date. So you can either use this CSV file that I've included for you. You can also create your own or find your own via Kaggle or Quandle or any kind of API or data set, preferably open source, that allows you to grab data. And you just need these columns of the index, the date, and the value of your stock, whether that's a crypto, which is what we're doing in this course, a cryptocurrency, or any stock. Okay, next up, now let's actually take this CSV file and let's bring it into our Colab here. So how do I take a CSV file and bring it into this Google Colab? Well, I'm going to create a new code cell, and first I'm going to import from google.colab the files module that I'm going to call files.upload. This is going to prompt me to upload a file to the Colab. So anyone who runs the Colab will know that that's what they have to do. So I can run this code cell, and it's going to send me a prompt to select a file from my computer. So I can hit choose files, and then I can select our CSV file, which I called bitcoin_prices.csv. And once you get the message here, 100% done, that means the file has been 100% uploaded, which means you can now reference this file in this Colab. And if you click on this folder icon, you'll see that the CSV file will actually appear here in your files. These files, they represent the files of your Colab, and they will refresh every time the runtime gets refreshed. For example, if you refresh the page or you close it and come back, you'll have to then re-upload the file. Now, the other option is to use a file from your Google Drive. So you can actually mount your Google Drive to the Colab, and you can select this CSV file from your Google Drive if you'd like. First, you have to upload the file to your Google Drive, then you have to mount to Google Drive, and then you'll be able to reference the file from your drive by going to /content/G drive as the path, and then / whatever the name is of your file. So there are many different options for bringing a CSV file into Google Colab. This is the most straightforward way. All right, so now we have that file here, and we can reference it by its name. For example, I can take the CSV file now and I can convert it into a pandas data frame. A data frame takes some kind of spreadsheet like a CSV file, and it can convert it to a much faster and more efficient type known as a data frame. By converting your CSV files to a data frame, it's very commonly done, and the benefits are that it's much faster in terms of processing, and also it opens up a whole library of sophisticated functions. Let me show you an example. Right, so below this first code cell, in another code cell, I'm going to call the pandas library. So first I do have to import pandas. Pandas is a very popular library for data science and machine learning, very commonly used. And I'm going to use the function readCSV. This function is going to take a CSV file, for example, bitcoinprices.csv. You pass it in as a string, so make sure it's in quotes. And this function is going to take that CSV file and it is going to convert it to a data frame. So the result is actually a data frame. Then I can show you what a data frame looks like just by pasting the data frame variable. Then I'll run that code cell and here we go. These are our results. Okay, so first we have an index column. So this is just the index, is not considered an official column. Then we have a column that says unnamed 0. So by default, it gets the first value there. And this is the column we had of indices. Then we have our date and then we have our value. All right, so let's say we want to clean up this data frame now. What if we wanted to remove this index column because it's now redundant? Now that we've converted the CSV file to a data frame, the data frame by default is going to have an index for each row. So we don't actually need this index column anymore. So how can we drop this redundant column? Well, I'm going to create a new code cell. And then I am going to call the data frame and I'm going to use the drop function. Here, I'm going to pass in the columns that I want to drop, either one or you can drop multiple columns at a time. I'm going to pass it as an array, even though it's just the one column. Then I have to pass in here the name of the column, which is unnamed 0. All right, and following that, I also have to pass in the axis. So that is going to be after that list. I pass in an axis argument. If the axis is 0, that means you're dropping a row. If the axis is 1, that means you are dropping a column. Then we can paste our data frame a second time to see our results. Okay, I'm also going to override the value of the data frame after I drop the column. And that's going to actually show me the change. So make sure you override the variable if you want the variable to be updated. All right, and great. That is how we can bring in our Bitcoin prices and how we can convert them to a pandas data frame, as well as how we can clean that data frame, how we can strip it of any columns that we don't need. Awesome. Okay, great. Now that we have converted our data frame, next we can format our data for Facebook Profit. So I am going to change the date and the value column names. Let's go ahead and make a new code cell here. We're going to take our data frame and we're going to use the rename function. Here, I'm going to pass in a columns argument. This refers to the columns I want to rename. The key is the original name and the value is the new name. So for Facebook Profit, we have to convert date to DS and we have to convert value to Y. Then I'm also going to pass in this argument known as in place, and I'm going to set it to true. So this means that the data frame actually will be updated immediately. I won't have to reassign the value. Then I can just paste the variable name. And okay, now my column names have been changed. Excellent. All right, next up, we are going to visualize our data set. So rather than just working with these numbers here and these dates, we're going to actually plot them on a graph. And this will allow us to see what kind of trend we have in the data set. So join me coming up in the next lecture where we will continue our project. Hello everyone and welcome back to our course. In this lecture, we are continuing our project and we are going to learn how we can visualize the data set of cryptocurrency that we loaded in. So I'm going to create a new code cell here. And first, I'm going to have to import a plotting library to help me with the plotting. I'm going to import matplotlib, and specifically its subplot library known as pyplot. So I'm going to import matplotlib.pyplot, and I can refer to it as pyplot for short with this keyword as pyplot. All right, now I can put to use the pyplot library. This library is very commonly used for building out graphs, charts, histograms, and more. All right, so I am going to use my data frame and I'm going to call setIndex and use the DS or date column as the index. Then I can call the plot function. Then I can call pyplot.show and that is going to show me a plot using that data frame. Let me hit run on this code cell and we'll see our results. Okay, we can see here on the Y we have the price of the crypto, and on the X we have the date. We can make the plot a little larger to make it easier to see, so I'll pass in here a fig size. This is a pair of numbers. First, the size on the X, let's do 20, and then the size on the Y, let's do 10. Then if I rerun this code cell, okay, now look at that. My graph is a lot larger. And now we can actually see the dates. So we don't see every single date this time. We just see several increments. For example, beginning at 2016, January 1st, and our last increment is October 16th, 2020. And we can see here how the price of our crypto changed over time. So we can see we had 2 big dips and then 1 large dip at the end. All right, next up, we can also as well change the type of plot. So for that, I'm just going to set pyplot.style.use. So this allows me to use a specific type of plot for my style. For example, I could use ggplot. There are several types of different styles. ggplot, look at this, it creates a graph here, and the color changed from blue to orange. This is just a bit easier for us to see because we have these lines at every increment. All right. As well, we can set a title and a label for the Y and X axes. Typically, you will want to have that all included whenever you're building a chart. We also have a legend at the top right. If you can see a very small legend, shows us what the orange line means. It means Y. And what was Y? Well, Y is that column here, that column of the value of the crypto. All right, so let's add here a title. So for the title, what I'm going to do is save the result of this, which will be my graph. Then I can call my graph, and I can use the set title function. I'll call this daily crypto prices versus the day. Then I'll hit run, and now we'll have a title. Typically, your title will be your Y-axis versus your X-axis. So let's also label the X and Y axes. So I'll take my graph and I'll use the function setXLabel, and I'm going to set the X label to be the date. Then if I rerun this code cell, it's just going to be more clear. Instead of DS, now we have date. As well, we can set the Y label with the function setYLabel. I'm going to set that to the crypto price. I'll hit rerun, and okay, there we go. Now we have our visualization. So this gives us a better idea of what our data set contains and what the trend in our data set is. It's a lot easier to understand the trend in data when you're working with a visualization rather than a spreadsheet or a table. All right, awesome. Now that we have our data loaded in and we have a better understanding of it, coming up next, we are going to start using Facebook Profit to build out a model and to predict future crypto prices using that model. So join me coming up in our next lecture. Hello everyone, and welcome back to our course. In this lecture, we are continuing our project, and we're going to start using Facebook Profit to build out a model and use it to make predictions. We're going to use it to predict the future stock value of a crypto. All right, so first steps first, let's hop back into our project and let's make a new code cell. Before we can use Profit, we do have to import it. So we are going to import from FB Profit, the Profit class, and we can just refer to it as its name Profit. Then we can run that code cell, and just like that, we'll be able to use this Profit class. For example, I could paste it for you, and here we go. We can see that it's from Facebook Profit.forecaster.profit. All right, let's now create a new model using the Profit. So I'm going to create a variable called model, and I'm going to use my Profit class to instantiate a new Profit object. Here I'm going to pass in my interval width. This can be a constant that I'll call interval width. All right, and this can be any value that we want to start with, for example, 0.9. We can also determine whether we want daily seasonality. I'm going to set that to true. That is going to create the model for us. Then we have to call model.fit. We're fitting our model through our data frame, which means that our model is going to train on the data frame. All right, let's see. You just have to make sure we define interval width with an equal sign, not a subtraction sign. All right, here we go. And just like that, we have fit the model through our data frame. And that was the training portion. Now we can use it to make a prediction. All right, so I'm going to create another code cell. I'm going to grab my model and I'm going to use this function make future data frame. So we are going to create future dates because currently our model trained from 2016 to the end of 2020 and just up to March of 2021. We're going to create some future dates. Now that's just one option. You also could, for example, take 80% of your data set and use that for training and then use the remaining 20% for the prediction. That's another option. But we can make a future data frame. So for that, I'm going to set a number of periods that we want. Let's define this number of periods. For example, we could do 100. And then I'm going to pass in a frequency argument. We want D for daily. And this is going to be a future data frame of dates in the future. So if I paste this out, I can show you what we get as a result. Okay, so this time we start at 2016, but we also this time go longer. So we're going past March 2021, which was our last day inside of the initial data frame. We're going past that and we're creating more. So how can we now predict these future values? Well, let's make a new code cell. I can call model and I can use its predict function. Then I can pass in my future data frame. And the result is going to be our model's prediction. All right, and then we can paste the results of the prediction. Let's just give it a minute and look at this. The result here, we get this data frame. The first column is the date, then we have the trend, then we have y hat lower, y hat upper, and after that we have trend lower and trend upper. We have additive terms lower and additive terms upper. So that's showing us the range of values. We have daily, daily lower, daily upper, weekly, weekly lower, weekly upper, same with yearly. Multiplicative terms as well, the range, and finally a y hat. All right, we can save this prediction for future use as well. So let me make a new code cell and I'm going to call this my 100-day prediction. So let's just see 100-day. So we can't start our variable names with a number, so I'm just going to call this prediction 100 days. Okay. And I'm going to get my prediction, and at the y hat column, that's what I'm interested in, I'm going to get the location at -1, and I can paste for you the results of that. So here we're getting the last value, 38,190. That is what the model predicted is going to be the last value there at the last day. The reason we want to save that last day is because what we've done here is we've done prediction using daily data, but coming up we're going to also look at monthly and weekly data, and we're going to see the difference in our results. So what will be the final price after 100 days for our forecast if we're using different intervals like daily versus weekly versus monthly. So this is our final price using our daily prediction. All right, coming up, we are going to analyze the performance of our model. We're going to calculate the performance metrics and also perform cross-validation. We can also visualize the cross-validation and also the accuracy or error of our model. Join me coming up where we are going to work on that. Hello everyone, and welcome back to our course. In the previous lecture, we learned how we can predict price with Facebook Profit. And coming up in this lecture, we're going to learn how we can analyze and visualize the model's performance. Okay, we're going to start with cross-validation. So I'm going to create a new code cell here, and I'm going to import from Profit the cross-validation function. So from Facebook Profit dot diagnostics, this allows us to get diagnostics about our model. I'm going to import cross-validation. Then I'm going to create here cross-validation. I'm going to call the function. I'm going to pass in here first my model. Then I can pass in an initial here, which is going to tell me how many days I want. I'm going to do 900 days. Our period is going to be, let's do 50 days. And our horizon is going to be 100 days. All right, so the horizon is the total interval. Initially we had 900, and the period is going to be showing us every 50. The result of this is the cross-validation of our data frame. So we can call this data frame cross-validation. Then we can paste out the results, which is going to be a data frame itself. So let me here paste that variable and run this code cell. Just give it a moment, and once it finishes its 18 runs, we'll see our results. So here we can see the profit is making 18 forecasts with cutoffs between 2018 of here July 27th and 2020 November 23rd. All right, so just give it a moment to complete all of its epochs. If you want your cells to run faster, you can also go to runtime, hit change runtime type, and enable a GPU. That's optional if you'd like for the models to run faster. Awesome. Okay, and once you get this 100% notice with the green bar, that means you've finished completely. So this time, the results of our data frame actually begin in 2018 in July instead of 2016, which was the beginning of our initial data set. And as well, it ends at here, March 3rd, 2021, which is where we ended as well. All right, and here we have a lot fewer columns this time, only 6 columns, the date, the y-hat, as well as the range of the y-hat, and the actual y here from our initial data set. Okay, next up, we are going to see our performance metrics, or our error of our model. So let's create a new code cell here. And from Facebook Profit dot diagnostics, I'm going to this time import the function performance metrics. Then I'm going to call that performance metrics function. In here, I'm actually passing in my cross-validation data frame. All right, and the result here is going to be our performance data frame. Then I can paste that variable and run the code cell. And look at this. Now we get a different data frame of different columns. So let's take a look at all of these. We have 91 rows by 7 columns. So here we have the horizon, beginning at 10 days and going up to 100 days. This horizon is the agent's time to live. So if the number of steps an agent has left is changed, then the agent will behave differently depending on how many steps it has left. So this is the length of the agent's lifespan. Next, we have MSE. MSE, also known as mean squared error. This is a way to calculate the error of our model. Then we have RMSE, which stands for root mean squared error. So all of these are just different ways of calculating error. MAE, that is mean absolute error. This is a model evaluation metric often used with regression models like linear regression. We have MAPE, our next column here. That is mean absolute percentage error. And that is going to here give us this value as a decimal, but it can actually be a percentage. Then we have MDAPE, that is median absolute percentage error, which is the middle value of all of the percentage errors for a data set. And finally, we have coverage. This is the portion of the data set for which a classifier makes a prediction. Because if the classifier doesn't classify all instances, we may need to know the performance on a set of cases. This refers to the set of cases for which it is confident enough to make a prediction. And this also is like a fraction. So for example, 50% of the data set, the classifier is confident enough to make a prediction. So these are all different ways to measure the error of our model. Let's take one of these values, like perhaps MAE or MAPE, and let's plot it in a visualization. So I'm going to make a new code cell here. From facebookprofit.plot, I'm going to import a function to plot our cross-validation. This is different from matplotlib or pyplot. I'm importing plot cross-validation metric. This will be a really easy way for us to plot our cross-validation. So I'm going to call plot cross-validation metric. Here I'm going to paste in my data frame cross-validation. All right, and we can see here data frame cross-validation. And from this, we can actually grab different metrics than the data frame itself. For example, we could grab, let's see what I just do. We could grab one of the columns in the performance data frame, like mean squared error, right? And I can pass that in as my metric argument and then run the code cell. The result is going to be this graph. So on the y-axis, we have the mean squared error. On the x-axis, we have the horizon, or the days. We have all the data points representing our data, and we have our line of error. Right? Here we go. And here is just duplicated, but don't worry about that. They are the same. Okay, we can also plot other metrics. For example, you can plot all of these really. Let's do RMSE next. We just have to change the metric and rerun the code cell. This time we get RMSE, also known as root mean squared error or root mean square deviation. All right, so we can get RMSE versus days. We can do this for every metric. So let's do MAE and MAPE as well. So I'm just going to copy that code cell and pass in here. Oh, didn't mean to open that. I'm going to pass in here, not my CSV file, but my MAE or mean absolute error. All right, here we go. Next, we had a different metric, which was our MAPE, mean absolute percentage error. You can see here. And one more we had our MDAPE, or our median absolute percentage error. And there we go. So we can see all the different values that we get for error. All right, coming up, we are going to next visualize our model's results so we can actually see what the model managed to forecast. And we can compare that with the actual values that we have in our data set. So join me coming up in our next lecture. That's going to give us an even better understanding of how the model performed, because we're going to have a graph where we will have two lines, one for the model's prediction and one for the actual data set. Join me in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.